Hi everybody. Once again, Dr. Salim is here with you guys. So this is part two of the Doppler studies. Just we had it. It's not completed yet for the color Doppler. This is the section two or part two. Let me share the screen with you guys and complete the color Doppler with a few more slides, and then we will be done for this study actually. Okay, so I hope you guys can see the study. Okay, we can see here too again. This was. Still the continuation of what we had it earlier. So Doppler shift. Remember, guys, we just said your best angle is to be for the color Doppler. It has to be the zero angulation. You see the pulse are coming straight here down, and the flow or RBC is going straight towards the pulse. That is like the best Doppler angulation because you will not miss even a single RBC. You can see a very tiny small flow. It will be visible because all pulses will just interact them and will give you the information. And that in that case, it will be a positive Doppler shift. But in case if you see that the flow is going down and the pulses are also going down, you will get a negative Doppler shift. Just we could talk about them. It will represent also in a pulse wave. Also, we're going to talk about the pulse wave the next session. But just to give you information, you see the flow is coming from this direction and going all the way to this direction, and you get a positive Doppler shift. Baseline is zero. When you're completely with a 90-degree, you do not have a Doppler shift in that case. But again, if you go more this way, more the flow is going away and the pulses are also going behind them, you will get the negative Doppler shift. It's just for identification to give you this. Even a pulse wave Doppler, we will talk about them next time. You can see here too, like this one, if the flow is going like up and down and your probes are like this way, so you are making perpendicular angulation with the vessel. That's a 90-degree angulation. You will not get any Doppler shift. Flow is there, but you cannot see it. This is like the best example, I will say. This person is scanning one of the artery, pretended it is radial artery, and he is looking for this vessel. The vessel is there, the box is on, the color scale is okay, the color gain is okay, everything is okay, but you don't see the flow. This is an artifact. That's why do not scan with a 90-degree. You see that it's completely 90-degree perpendicular to the vessel, to the scan. You see that? Vessel is visible, but with no color. That is called error. That is artifact. So the 90-degree with a color Doppler is the worst Doppler angle. The flow will be there, but you don't see it. Now look at here. This main portal vein is getting towards the flow is going towards the transducer, correct? It's going that way, and it looks red for us. There is a small hepatic vein or something. You see that looks blue, so that's away. But here is the main question. This area looks empty, no color. And it does not mean that there is no flow. There is a flow, but because somehow that angle is completely 90-degree for the main axis beam, because the flow is going this way and the beam is coming down. So they completely make a perpendicular 90-degree. That's why we do not see the flow in that case. 90-degree is the worst Doppler angle. Never ever scan with the 90-degree. Look at here. This is a 90-degree, no Doppler shift, but oppositely completely. Look at here. This RBC is going away. It doesn't matter, away and towards, that's not a deal. But the thing is, you will get a zero angulation and your Doppler shift is 100%. Because cosine of zero is 1. 1 means 100%. So in this case, your angle is 90-degree, but your Doppler shift is 0 because the cosine of 90 is 0. And 0 means 0% Doppler shift. So remember, this is very, very important for us to put the correct angulation. For the vascular Doppler peripheral arterial system, when we put the pulse wave Doppler, our angle range is from 45 to 60 degree. But 60 is optimum, optical. Why it's optimum? The reason is because the cosine of 60 is 0.5, and 0.5 means at least you have 50% Doppler shift. That's what it means. Okay, let's see the next one. So we have again color Doppler. Once again, I will represent this to make this phenomena more clear. You see there are two vessels. One is feeding the kidney and the other one is draining the kidney, right? So now this is a renal artery. The flow is going towards the kidney, and here is the you see that the pulses are coming from this source. The probe is here. So this flow is going towards that where the pulses are coming from, to the probe side. So that's why it represents as red, because this is a positive Doppler shift. You get more flow from this. You get more frequency from this compared to the operating frequency. But meanwhile, you see the renal vein, it's blue. Why? Because the flow is going away and the pulses are also going behind them. So you get less reflection from this vein, this renal vein. So this is a very best example for our Doppler shift away and towards, I would say. So I just bring this color so you can see more better. Again, that artifact, remember we were talking about, if somehow this angle is almost like a 90 degree for this vessel, but here it's not 90 degree. It's a little bit, you see this is a CCI, the flow is coming this way and the pulses are coming that way. But what happens, because this is a positive area, now they did not invert it. You should invert this portion, but our case is here. Look at here. This vessel, it looks like there is a maybe like an plug buildup, like a soft tissue plug buildup, or maybe somehow inflammation is going on that vessel or that artery. The reason is it's not filling the artery. It's the box is there, the color shift is there, everything is there, but it's not filling because we're using the wrong angulation. If the vessel is not filled with the color, so for operator, it looks like there is either soft tissue plug buildup, or there's a compression, or there's an inflammation. It means there is less flow. There is a problem. There is a pathology. Somehow we have to rule out, but it's not a pathology. There is no pathology going on. It's just the physics is wrong. We're not adjusting the physics on that case. This is a 90 degree. Okay, like you can see here too. And the aortic arch, look at here, ascending aorta, descending thoracic aorta, but this is completely 90 degree angulation on that area. You don't see any flow on that area. It looks dark on that area. You can see on that picture. It looks dark. Or somehow here, this area for this color box, it looks like maybe completely 90 degree, exactly 90 degree. That's why we have no flow. Here it's away, and here it's towards. You see the flow, and it disappear and then appear again. It looks like this area is more than 90 degree, maybe 95, 100 somehow. So the flow is going away. Here the angulation is maybe 85, 80, 82, 80 something, 89 even, but not 90. When it become 90, everything is gone. Okay, this is like the best, we can say, a diagram which we can tell us, like here the flow, you can see this flow and this flow, where the flow is completely towards the probe. You see it's going towards the probe. That is a Doppler shift, which is positive, and that's why it looks red. Here the flow is from the probe, it's going away, comparatively it's going away. When it becomes exactly 90 degree, no Doppler shift is seen. Remember, this area is a baseline. So here you have a reflection. Keep in mind, for your reference, you have a reflection, but transmission and reflections are equal. That's why you don't see the difference. They're equal. So we can say 5 minus 5 is 0. Correct? So you don't see any Doppler shift on that area. Do not scan with a 90 degree angulation. Now, the color bar can give you two types of information. One, it's called velocity mode information, and the other one is called variance mode information. Velocity mode we study this from up and down. So anything close to the baseline is slow flow. Represent any flow which is slow flow. Any flow which is very away from the baseline. Doesn't matter if it's on the positive shift or if it's on the negative shift, but away from this baseline. This is a baseline, it's a zero line. Anything from the baseline, you see the color change, correct? You see the color very dark red, and it's light red, and it become even yellow. Same thing here, dark blue, and then light blue, and then it become green. So it means the color bar on the top portion is the highest velocity, close to the baseline is the lowest velocity. Somebody may simply ask this question from you, that from the color bar, what does the color change up and down represent in a color bar or in a PRF? It's called PRF. Half of this is called Negues limit, correct? So we can say that's the velocity information. Close to the baseline is low velocity, away from the baseline. If it's up or down, doesn't matter, negative shift or positive side. That will be a very high velocity away. Now, the other information is called variance mode information. This will also give us, you can see in this information, like this color bar, you see the more dense color you see on the left side, light color you see on the side. Same thing for the negative shift. Now somebody will ask you this question. What type of information you get from the color will change side to side in a color bar? What kind of information you get? Remember, number one, it's called variance mode information. And then we get the information that is the nature of the flow. It tells us about the nature of the flow. That the flow is normal laminar physiologic flow or is it turbulence flow? That is very important. Somebody may ask you what type of information you get. And here we get the velocity information on here. Remember, that may help you if you want to teach your students or if you're setting for one of the national or international examination. Again, artifacts can be there. So remember, half of this is called Negues limit. So this is a zero line or baseline. Above that is a positive Negues limit. Below that is a negative Negues limit. The whole thing is called PRF, pulse repetition frequency, or color bar, or color map. These are the names. Now, sometimes what happens, remember, the normal way is, like for example, it has to be in the middle. The baseline, normally it has to be just in the middle. But like for example, if it's 82, 84, 84.7, that's the plus. It's supposed to be also 84 here, negative. Because this is 38. Why? Because they move the baseline a little bit down. If you bring the whole baseline down here, it will give you one number in that case. So it, for example, if this was 50-50, so the baseline is here, that will complete 100 in that case. So remember, this is important for us. The baseline has to be in the middle. Now, if in like this one, you see plus 40 centimeter per second and minus 40. This is the room for the negative shift, and that's the room for positive shift. Now, if they are not in a correct way, for example, look at this one. This is possible artifact we get. This is not a pathology, it's an artifact. What happens? This velocity is a lot higher than this scale, or we can say this Negues limit. Here the Negues limit looks like 10.5 centimeter per second. Same thing, minus 10.5 centimeter per second. Maybe this flow is 30 centimeter per second, maybe 50, maybe 60, 70 centimeter per second. It means the velocity is very high, but the scale you're using is wrong. So remember this one thing always. The flow velocity should match to the scale or the Negues limit here we have. So now we can get this information. If you're scanning on arterial study, remember, increase your scale. There is a knob, it's called scale or color scale. So you can, or PRF, you can increase to catch the flow. For the venous study, any slow flow, very slow, maybe it's artery, but slow flow. Remember, bring your scale down for that to detect the flow. Go with the speed of the flow. We, like, as a medical professional, we understand the venous flow is a slow flow, it's a phasic flow, and arterial flow is a pulsatile flow, it's a speedy flow. We should look to the scale where to increase, where to decrease to detect the flow. Now, if you represent this flow somewhere, it looks like there's a post-stenotic turbulence flow. Maybe it's a soft tissue plug buildup. We don't see it, but there is a two colors. This is not correct. It's not a normal laminar flow. It's a turbulence flow. It represents, even though there is no turbulence. It's just because the problem is with the physics. We are not going with the flow. The scale is lower than the flow speed, actually. Should increase the scale in that case. You can see here, this area is the highest velocity area. The rest is okay, but here you get a different color because of you get this area. Maybe that 37.6 is not enough for this center of the artery because that's a very high speed flow. So if you make this 37, maybe 40, maybe 45, maybe 50, it increased. If this increase, this also increase. Equally they increase, positive and negative. So this will disappear. Same story here. Because of this 10.5, if you make it 50 centimeter per second, this will also get 50, the bottom one, this will disappear. If this was a pathology, with a change of the scale, it will not change. Because it's a pathology, it's pathology. So remember, always remember, go with the velocity, adjust your scale. We cannot adjust the velocity inside of the vessel, but at least we can adjust the velocity of the pulses which operate that vessel, and that's your scale. Remember, that's important for us. ARDMS may ask you that question. They will give you a picture like this, will tell you, adjust the physics. You see there is a knob, it's called scale or PRF. If you have this problem, increase it. There will be another problem. They may give you a vein and you see the box is correct, everything, the vessel is dived to the right, the box is steered to the right, and you still don't see the flow. Maybe what happened in that case, the flow is very slow and your speed is too high. You're selecting very high scale here, but the flow is very slow. In that case, you don't see the flow actually. The vessel look empty. So in that case, you decrease the scale. So remember, if they give you a color like that, it means the speed of the flow is high, the scale is low. Increase the scale. But if they give you opposite way, they give you a vessel like this, but that's empty. It looks unechoic inside. So it means your scale is very high. Maybe the scale is in 100 and the flow is going in a 5 centimeter per second. So decrease the scale in that case to visualize, to detect the flow in that case. Do not forget that. That's important. Here you can see. This is also, it's also like an artifact, we can call it, but it's a pathology. It's a reverse flow. But just our thing is like, it looks like the flow is going to all direction. Now, here you can see the flow is coming towards, it's a red color. The flow is going away. It's supposed to be not seen in here. So it means this is a pathology. You can see there is a mitral valve is leaking. So that's a pathology at least, but we know that's a turbulence flow, away flow. Supposedly it's supposed to be closed, correct? Or here you can see if the flow is going that way, that's a stenotic area. Post-stenotically, you see a turbulence flow. Here the flow was going to one direction. Here the flow is going to all directions. Okay, that is important for us also, just in case somebody asks you that question. Okay, all these information, I just collect them and prepare this book for those healthcare providers who want to have this book. They can have it on our website. The soft copy is available. But if you want the hard copy, we can send it worldwide to your house, to your door. Just give us a call and let us know. We will send it to you. And they're not expensive, they're very cheaper. So this is for all the lecture notes, all the explanations for what just we study about. Just we study only color Doppler. There's all the Dopplers are here. So you will have the complete understanding. It's just I collected in this book from different books and from my own experience. And I made it more easier to for the understanding, to clear your concept for the vascular Doppler. And then I made a question bank. Also, some people learn from the questions from a book. So this is a book of question bank, which are 730 multiple choice questions, all regarding vascular Doppler and all Doppler shifts and all related to the Dopplers. So this is if you want to sit for RV2 or RVS exam or any other exam. So this is all the questions you may, and also the key is also there, so you can have that too. And then in case if you really want to know a little bit more, so you can come to our website. This is our website. And also if you have any question, confusion, why not? If you need suggestion, let us know. These are our international WhatsApp numbers. And then, of course, YouTube channel, you can see it. Please, if you think these information are really important and I can explain something easily and you get the concept and clear the concept, why not? Please share these information with your friends who are in this field. And then we have some more information too. We're going to do them later, like pulse wave Doppler and continuous wave and all those things. We will discuss all these things on the next session. So please just wait for the upcoming videos. And please do not forget to subscribe the channel. And this way you will get the notification for upcoming videos. So once again, this portion, this segment and the previous segments, they are get together. Please watch them together. That was segment 1 and this was segment 2. Watch them and you will get the complete concept will be clear for related to the Doppler shift. Still, if you have a question, please let me know. Take care and see you next time.